When we write mathematical proofs, we often need to use the definitions of the concepts that appear in the statement. In this video, I will illustrate how to prove that an example does not satisfy a definition. I want to prove that the function g, defined by the equation g of x equals cos x, is not increasing on the interval 0 pi, and I want to do it directly from the definition. Like in the previous video, this proof is short and perhaps not that important, but I have a bigger point to make. I don't need to have learned how to do a proof of this type in advance. I don't need to memorize any method, as long as I know my definitions. I know the definition of increasing, and I can simply use it to get the definition of not increasing. To say that g isn't increasing on an interval I is to negate that g is increasing on the interval I. So I will write first the definition of g is increasing on I. For every x1 and x2 in I, if x1 is less than x2, then g of x1 is less than g of x2, and then I need to negate this. So I want to write that it is false that every pair x1 and x2 satisfies the implication. That is the same thing as saying that there exists one single pair, x1 and x2, that does not satisfy the implication. And finally, to say an implication is false is the same as saying the if part is true and the then part is false. If this feels a bit foreign, I invite you to rewatch the video where I explain how to negate a conditional. It is very short and I will link it in the description. And that's it. I have the definition of g isn't increasing on an interval. If you have a little bit of practice, perhaps you could have written the negation right away, in one go. That would be fine. If you need to break it into steps, that's also fine. Either way, now I know what I need to do. I need to prove this statement. This proof is going to be shorter than the previous one. Let's sketch a graph of the function. Let's write down the proof. I need to prove there exists a pair of elements that satisfy these two inequalities. The simplest way to do that is to say what the values of x1 and x2 are, and then verify the two inequalities. And there are lots of choices I could take. Pretty much any pair you choose here will work. I'm going to choose 0 and pi over 2, which is here and here. And then I only need to verify that 0 is less than pi over 2. Check. And g of 0 is 1, which is greater or equal than 0, which is g of pi over 2. Check. And that completes the proof. And of course, if I just wanted to prove that the cosine function is not increasing, there are other things I could have done. It wasn't necessary to do this. But that wasn't the point. The lesson learned is that I can do the same thing not only for increasing, but for any other mathematical constant.